also known as new space. I did want to define it a little bit. I feel like a lot of people might be familiar with the term, but it is the new generation of space industry. It's the evolution of technology and business practices in space exploration. And it's comprised of private companies, entrepreneurs, and Space 3.0 gives the idea that there is a Space 2.0 and a 1.0. So 1.0 being government, like think of Apollo age space industry. Space 2.0 is the privatization of space. So think of defense and contracting companies. And they all contribute to and profit from new innovative space industries. And today we're really fortunate to have so many fields represented here. We have JPL, and as you may know, we're up the street. It's concentrating on heritage, science, and exploration. We have Millennium Space Systems, which is a Boeing company that is specializing in rapid response, small satellites, and defense. And finally, SpaceX, the next generation satellite bus manufacturer. I'm sorry, Apex. I'm sorry, Russell. Too many X's. Already messed it up. All right, Apex Space. Next generation satellite bus and manufacturer. Way better than SpaceX, for sure. And that's on record. Okay? So I'm really excited to have you all here. I'll just give a quick introduction on each of the panelists. So starting off with Joey right here on my right. Joey is a senior mission operations engineer at Boeing Millennium Space Systems. He's also a musician and science communicator. Up until very recently, he was also at JPL, specializing in running really great missions like Voyager, Cassini, Mars 2020. Celeste, next up, is a software engineer at JPL, working on technology for future Moon to Mars missions. And Russell at Apex Space. Is a technical leader and founding engineer at Apex Space. He drives spacecraft software from concept to orbit. He's an expert on flight software, embedded systems, and team building with a focus on autonomy and reliability. So I wanted to ask you guys a general question, and then I'll get kind of into more specific catered questions for your industry. But I'll start off with something that really affects space, new space. If you could remove one bottleneck to accelerate the progress in Space 3.0, what would it be? And I guess I'll start off with you, Joey, since you're the closest.
Yeah. Thanks for having me, everybody. I would probably say access to launch. I think that right now, like the way I look at it is in aviation, when we were innovating aviation, all you needed was a runway, and you can rapidly test new iterations of the airplane. Right now, as we are rapidly developing spacecraft, especially miniaturizing it, it's still very difficult and expensive and slow to get something into space. And so I think that bottleneck would be really nice if it was gone. Yeah,
yeah, definitely. Celeste?
Yeah, so I think that access to information is also like a bottleneck. So like with more like companies and like private individuals getting involved, there's like that barrier of like proprietary information. You've done your testing and you don't want to necessarily share it with your competitor. But also like at JPL, we run into export control issues. So for anybody that doesn't know that, although in electronics you run into that a lot. So the US government doesn't want export of information. So like cryptography is like a very good example that is export controlled. But like JPL, one of their missions is to publish information, make it available for companies and other individuals. But a lot of the time, it's either unclear if it's export controlled, and like nobody wants to make a decision if it is, or it is export controlled. So then you kind of just have to like hold on to that information, and not everybody can benefit from it. So I think some relaxing there, especially as like the rest of the world has caught up to the U.S. on space exploration, relaxing that I think could bring everybody forward in the industry.
Totally.
And I think I would eliminate the regulatory bottleneck. There's more satellites that have been launched in the last few years than the last 60 years combined, and I don't think our regulatory frameworks have really kept pace with the industry. It's difficult to get an FCC license. There's a lot of antiquated requirements that are leveraged on companies, especially modern 3.0 companies, and it's slowing down the process. And I think the industry and our regulatory bodies need to come together to sort of figure out what the framework should be going forward.
Yeah, definitely. Like, I think right now we're seeing a lot of growing pains of these heritage companies working with venture capitalist companies, companies that are driven by like market exchanges. So I guess this question's for you, Joey, because you're sort of have your foot in each door, startup world and part of this bigger heritage company at Boeing. What kind of in this new era of reshaping the relationships between the government and commercial and defense sector, they're also different in practice, but what is exactly reshaping the new era?
Yeah, I think it's definitely the increase of commercial companies for sure. And that has its benefits and its drawbacks. Prior, all we had was really larger defense companies, and most of space was driven by space agencies and national type funding because it was very difficult, very complex, and very risky. Now, with all of these different technologies that are being innovated, we're seeing so many different commercial space companies enter the space, and I'm worried that missions that are very pure science missions are going to be kind of crowded out.
Right, like the Cassinis and the Europa Clippers.
Not a big profit margin for going to an orbit around Neptune, right? In a very short gain.
Cool pictures, though. Lots
Exactly.
of cool pictures.
Excellent pictures, great backgrounds for your monitors.
Yep.
But to me, there is real long-term value for going to Neptune. Like your cell phone cameras have CCDs and CMOS were created by Bell Labs, but matured by NASA. Their star trackers now used in commercial space companies are really because NASA did that legwork. And so I think not crowding out science missions and not taking away funding from places like JPL, if you catch my drift.
Amen.
Is so highly important and everybody benefits. And so I'm worried that the relationship is changing for that reason, but I hope in pushing out the message that national labs are very important.
Definitely. And yeah, like you said, like JPL's kind of like puts something out there into the world and becomes like a benefit to many companies, even starting up some companies. Something that I've talked so much to you about, Celeste, and I'm a fangirl of F Prime, which is open source software, flight software at JPL that a lot of companies have been using to prototype. And I know you've kind of gone around different cities, different universities, smaller companies, and done workshops. So my question is, what advice would you give a startup that wants to use F Prime in production and not just prototyping?
Yeah, so I don't know if anybody is familiar with F Prime, but it's open source on GitHub, so you can actually go and see all of our commits and what's available. So I think kind of two parts to that answer. The first one is, so F Prime does offer like a ground system, so something that you can immediately start talking to your flight computer on. So the ground software for that, and it is meant just as like prototyping. So one of the first things would be to go beyond, or at least plan on going beyond the F Prime ground data system, and like either developing your own or using another open source tool. I think that that's somewhere that companies can get stuck, is trying to rely on that, and it just doesn't have the features that like a full ground system would have. And then also using design patterns. So we recently did get some funding to do a lot more documentation on design patterns.
That's awesome.
Yeah, so like following those, having like a manager worker. So like the manager is what is like talking to the rest of the system, whereas the worker is like where your heavy like algorithms are running, so that you can efficiently use your multi-core, multi-threaded system. which I think that answer got a little bit technical.
I
But
love it.
yeah, making sure that your like software is built for reusability. Make sure that like your high-level application components aren't specific to the like driver or hardware that you're using, so that if you do want to like switch flight computers later on, you only have to switch out like the bottom layer. You don't have to like rewrite all of your applications, and that's something that we've demonstrated on some JPL missions.
Very cool.
yeah.
I really hope to see more of that, like this open source community within like kind of an old heritage company like JPL. And I want to ask you this, and feel free to pass if you'd like, but I want to see how you kind of envision the relationship that JPL has with private sector, because I'm sure maybe some people have just either come to you for questions or even workshops. So how do you see that relationship evolving as more and more organizations adopt and contribute to that open source space software?
Yeah, it's been really rewarding actually seeing like the relationships like grow. F Prime was originally meant for small scale missions, so something that you need to like rapidly develop on like a lower budget, so you only have like a few developers working on it. And we actually first were talking to university CubeSat teams and making something that university students can use. And now as F Prime has gotten more flight heritage, more documentation, more reliability, commercial companies have started using it. So there are actually like a few companies like in the LA area that are using F Prime. We have workshops like in the area fairly frequently. So they actually like came to our workshop. We're like, actually, this is a really cool tool. Like we're going to use it. And not only have they used it, but they've also contributed back to us. So we have gotten pull requests like sort of out of the blue from these like companies that have started using our product, which is really cool. And we'll actually have companies want to go the other way too. So companies that come to us that are like, hey, you know, we just need a little bit of like help, you know, developing this thing. And they can actually partner with JPL to do that now, which is really cool.
That's good. We
Yeah.
need some of that partnering up, that diversity of funding.
Yeah.
Yeah.
go
Funny
ahead.
enough, Apex is only 3 years old, so when we were founding, we actually went to JPL and talked to some of the
I didn't know
F-Prime
that.
folks. And it was really useful to not only like be able to look at the code, but also to have like a community of people that have done flight software before. I think it really helped sort of set the path for some of the software at Apex Space. So I love F-Prime.
That's awesome. I think we have stickers. Yeah, speaking of reliability and autonomy, Russell, while we have you here, did I tell you how much I like Apex?
That's 2, all right.
So with these kind of faster iteration cycles, you know, these satellite buses coming online super quickly, how do you balance that speed and reliability in a spacecraft design that has to work and can't just, you know, like fail and hurt people falling out of the sky?
Well, that'd be really bad if a satellite hurt people. You often think like speed and reliability are opposite and opposing forces. The faster you go, maybe the worse it is. And that is true in some cases, but at least with satellites, they have to work. You can't go up there and reprogram them if you mess up. It'll be a brick in space, unlike maybe a laptop or a badge. You can reprogram it if you make a mistake. And so there's a certain bar of reliability that a satellite has to have, you know, full stop. So the question is, how do you meet that reliability while trying to launch hundreds of satellites in a single year? And I think with speed, I like to think you have to get creative of how you move fast. You need to parallelize certain efforts, leverage open source frameworks and heritage and things like that, and maybe not reinvent the wheel every time. I think that's going to be a key sort of strategy in order to meet the speed while still getting that reliability.
Yeah, and I just want to plug in that there will be a Q&A at the end, last 10 minutes, if anyone wants to get deeper into this. Were you going to say something, Celeste?
Yeah. Talking about that reliability, while I was, preparing for this talk, I was like thinking about, how the industry has changed, and like not only are you like parallelizing the process, but also like vendors have also taken this on. So like being able to use automotive parts, like having things that basically come off the production line and are ready to go into a satellite is like a major change from how space used to work.
Yeah, I was just touring Rocket Lab and they reminded me very much of a Ford assembly line, using COTS, our commercial off-the-shelf parts, and you know, at JPL, it's like building a Bugatti. Everything is very custom, it's expensive, and it's a one-of-one, you know. And I felt a big shift in that, in creating standardized, reusable, reliable buses, especially when they are flight tested and they are verified and validated. You know, you get the heritage, and then you get the reliability, and you get the speed, because you already know what you're doing. So, yeah, I think that's where it's headed.
Yeah, that collaboration really does go a long way. Like you mentioned, national labs earlier, not only at JPL, but kind of bigger, like companies that kind of go into a deeper and deeper research that, again, would be sort of lost if the funding is lost there from a federal level. So I guess to help out this industry and maybe for future collaboration, do you see these, Joey, do you see these collaboration models happening, especially in a place where, again, you kind of have that startup environment at Millennium, but it's tied to this bigger parent company of Boeing, which is Heritage?
Yeah, definitely. And kind of to the point I was saying before of like the importance of national labs to bring us some of the innovation, but also the importance of commercial to bring us some of the freedom. When I was working at JPL, you know, when we were commissioning a spacecraft, we would manually send a command, analyze what happened on the spacecraft, and then manually send another one, analyze it. And then I got to Millennium. They're like, oh yeah, we just put it in a Python script and it just goes and we just, you know, it verifies.
Bada bing, bada boom.
Yeah. And I'm like, okay, you know, this is very new to me. But it works. And I thought it was really interesting what they're doing with autonomy and AI and programming a lot of the mission operations to make it more streamlined and actually to try to reduce human error. And so I think having that balance between the two is really important.
Definitely. And Apex has this emphasis of factory scale satellite production. Millennium focuses on the mission tailored small sats, and JPL pioneers these big science payloads, at least for now. So for anyone here, how are the design philosophies evolving across your own organization?
Yeah, I mean, at JPL, they are like actively trying to work in exactly the philosophies that you were talking about. So not only like AI and like new technology, but you know, how can we like script some of our mission operations so that we don't have people sitting there on the console, you know, every second, making sure that everything is working okay. So JPL has, you know, somewhat been going through an identity crisis as, you know, Space 3.0, as you called it, like starts to really take hold. So it's been really interesting seeing JPL basically try to figure out like not only like the things that are working for commercial companies, but also like what's next for them. So like newer compute platforms, so that we can get more powerful processing in space, and also, you know, how do we you know, preserve our reliability? Like, you know, these are one-of-a-kind missions; they have to work. You know, it's not even just like a satellite that, you know, we're gonna make 100 of them and like all of them have to work. It's like, you know, one of them. And so, like, what lessons can we take from industry for how we can speed up this process and also, you know, maybe spend less taxpayer dollars on it, but still have like this super reliable process. So we've been looking at like smaller missions. Like we've done a little bit of work with like the commercial payloads office. So like the Intuitive Machines and Astrobotic, who are trying to like land on the moon, and we've seen like actually a lot of success with that. So yeah.
I think for my company, what's really changing is we're like at the third wave of standardization, if you will, right? With Industry 1.0, 2.0, 3.0. You know, there's like standardizations on protocols, on how the satellite will talk from the space to ground and things like that. And I think what we're, you know, kind of hitting is like, Apex builds satellite buses. So for those of you who don't know, satellite is not like a school bus or something like that. It's a platform that does all of the guidance, navigation, control, and the comms. You put a payload on it, maybe designed by JPL, it's a satellite. And so my company designs the bus. And some of the challenges we're hitting is like, okay, what's the standard way for the bus to talk to the satellite? it's not been really defined, and every single company and industry has a different protocol, a different software. And if we're really going to reach the scales and the amount of satellites that we need to produce, I think as like a community, we need to come together and standardize on how things talk, and maybe even adopt things from the non-space sector. I know Ethernet has made big inroads into satellite buses. I think previously the space industry has used things that have been designed only for satellites, and I think if we could leverage more commercial parts and commercial protocols, I think it'll be better for space overall.
Yeah, that's actually something that F Prime has been working on, is to support these common things. Like there are like certain space packet protocols that like a lot of like bus manufacturers are using. So like we've been like specifically trying to build those in, and then also like encryption and security. We need to agree on those as well. You need your ground system to be able to actually talk to your satellite. So figuring out how to like standardize that and still, make it secure.
Yeah, I think there was a big effort to standardize things as space was revving up in like Space 1.0, and especially working with other countries. But now that like space has been established, and these kind of like leaders in the industry are setting the standards and expecting everyone to follow, we're seeing that like, well, that's not the way things are done anymore. So I work in a really kind of like old heritage part of the space exploration, which is the Deep Space Network, supporting any mission that goes past the moon. So it's a lot of CCSDS standards, which there's communication in there, there's space in there, deep in there. Cumulative. I can't.
Space data.
It's a quiz now. Shouldn't have brought it up. But yeah, these standards, we're expecting people to just comply. But now that we're seeing companies who shall not be named that we are like starting to work with, they're like, oh, well, we don't want to comply with this type of PDU packet like frame, and I was like, okay, well, I don't even know what to say. Do I talk to my program office and tell them like, what do I tell this customer? Like, are we going to custom build this for them? But now we're finding ourselves in a predicament, because we want to be flexible. We want to be able to support multiple missions, especially if we're their only choice. But how do we like kind of start this collaboration? And with that, I want to ask, what do you think is really the next transformative big thing that can drive this industry? There's been, of course, a lot of talk about AI, miniaturization, manufacturing processes, or could it be something else?
Yeah, on the mission operations front, definitely AI. It's going to go from telling the spacecraft what to do to telling the spacecraft how to do it. And I'm seeing programs right now where they want to press a button and the spacecraft literally just does everything from commissioning to the mission all by itself, which is scary as somebody who likes to analyze, look at channels, make sure everything is within limits, and make sure everything's operating the way it's supposed to be before we move on to the next step. But and I think there is a push. There's like definitely a divide right now from people that want to use AI as fast as possible, and there's people that want to take their time. And I think the answer is somewhere in the middle. But that's a very big thing right now, for sure.
Yeah, we were having a conversation earlier, me and Russell, about like disruptive technology, and maybe there's a lot of negative connotations to the word disruptive, but disruption is good. It means that it can, drive an industry. It could help a university fly something to space that they weren't ever able to. So Russell, companies like yours maybe go after underserved customers that may need a product faster for a less price, but then they gradually improve and end up taking over. What technologies, something like additive manufacturing, software-defined payloads, AI-based autonomy, what would be the most disruptive in reducing cost and time to orbit?
I'll try to keep this software focused, because there's a lot of things in like supply chain, like ordering, kind of working out your supply chain, getting buses on the shelf. In terms of software, software-defined payloads, or for those of you that don't know, I had to look this term up, but it's just like payloads that you can update, you can update in orbit the software, correct? Cars have been doing that forever. So I think, first of all, the satellite industry just has to accept that you're going to update your software in orbit.
No, don't make me do it.
Yeah, it's the only way we're going to keep up with all of the changing things. It was quite a surprise to me, getting into this industry and realizing that was a faux pas to update the software on the satellite.
So that actually, like, fun fact, like Voyager.
First one.
Yeah, like
Reprogrammable memory.
that was launched, 50 years ago and actually had updatable software, which, we've been able to save the mission multiple times because of that. Sorry, go ahead.
Yeah, I blame program managers for not wanting to update software. Sorry. I think the most disruptive thing in my mind is probably AI, not to steal your answer, but maybe not in the way of like there's going to be AI running on satellites. I really think it's how we're going to use AI to develop satellites. At least at our company, it's starting to become integral to all of our software development practices. We use it to do our code reviews. We're using it to start to analyze the reliability and the safety of our code. We often, train it to look at some of our scripts and try to see if there's any issues with the fitter or the fault detection, isolation, and things like that. And even in the business, right, we're using it to like analyze candidates and like look for people that maybe not be on LinkedIn. It's really just infiltrating every part of, the process. And I don't think it's a bad thing. I think it's the type of thing that now it enables maybe one person to do the job of 5, which allows us to then just produce more things. Which I think will then lead to more satellites, lead to cheaper satellites, and cheaper satellites allow universities and things like this to get better satellites. So I think it's really going to be a positive feedback thing that accelerates space overall.
Yeah, exactly. I mean, with the Deep Space Network, again, it's been around for 60 plus years, and the amount of missions that we've supported went from like 5 to 10 to 30 to within the next year is probably going to reach to be like in the 90s of us supporting not just U.S. missions, but commercial companies from outside countries. And, they've just implemented a kind of a way to just have one operator do multiple things, because all of these missions are using the time, tracking their spacecraft, and how do we reduce the amount of time somebody comes over the net and asks a question about their spacecraft, and in their mind, their spacecraft is the most important thing. So why isn't this operator just understanding me, So we've implemented things like Follow the Sun, which is being able to control any complex from one of the stations. There's 3 different stations around the world. But even that is not enough, because there's still these questions that come up that an operator can't do. So now there's questions of how do we make the spacecraft command things to look for answers and not really even need the antenna to perform actions. So how can we make the spacecraft smarter at asking stuff, pretty much? So I think that's really interesting. And again, it's like there's such a big need for collaboration, because I feel like a lot of teams are working separately, not really understanding how the other side may work, how the other interface may work. And when it comes time to integration, things just end up falling apart. So I'm really glad we're having these conversations. Yes, Celeste?
I also think, like on the autonomy and AI side of things, like a technology that doesn't quite exist yet, but I think will further change, is when we can like verify and validate like this autonomous behavior like mathematically. So I was recently working on an autonomous project where we use a lot of different autonomy algorithms. So they're not like artificial intelligence, they're like actually just like, math-based, well, AI is math-based, but more traditional autonomy algorithms that you can, mathematically prove. And I think once we start putting this stuff onto spacecraft, we will need to be able to verify it in like a mathematically sound way. So I think, at least at JPL, I'm guessing that until we have that, we won't see too much of this like sort of unpredictable artificial intelligence like on the spacecraft. So I think that's also, something that we're sort of, tons of people are working on, but we need.
That makes sense. I'll settle for like a export controlled ChatGPT where I can just upload all these interface documents that I always reference but never actually want to read. We have that. Not in the DSN. We're working on it. Okay, so I'm just going to close out with this question and then open up to you, audience. If anyone has a question, just raise your hand. But as I kind of look to the future, what will the next decade of Space 3.0 look like? And what are you most excited and or concerned about?
I mean, okay, this is like realistic answer and like a fantasy, answer, which in the future you never know can actually happen.
That's dream.
But I envision on-orbit operations being really something that can change the game, and having autonomous spacecraft up there with spacecraft that are built with interfaces that can allow the spacecraft to repair it, to refuel it, to do things on orbit to drastically lengthen the life cycle. I think it'd be something that, be special and game-changing for sure.
I'm just excited about the scale. I think the launch industry, the company that shall not be named, has really brought down the cost, or really brought up the access to space. And now what we're seeing is a second wave of, satellite companies that are really trying to capitalize on that, mine included. And it's just a really exciting time. There's going to be lots of challenges. Maybe all the satellites will hit each other, and we'll have the Kessler syndrome, where it's really hard to get into LEO. I think we'll be able to solve that one, though. But I think with scale, there's a lot of challenges, right? How do you control 20,000 satellites in space? How do you make sure everything's operating correctly? Maybe AI is the answer. But I think it's an exciting time to be in space. And I'm really excited for maybe 100,000 satellites in space, I think.
And more satellites around the moon, maybe.
Yeah, constellations around Mars. I think those are the type of things within our lifetime that we're going to see.
Yeah, I'd also like to see some on-orbit manufacturing. So there have been a couple of companies that have tried to do that. Like there's a medical company that has, but they actually ran into regulation problems. So like going back
They had to land in Australia, yeah.
Yeah. But I think it would actually unlock some things that aren't currently available. There's also there have been ideas for 3D printing on orbit. Microgravity does a whole bunch of cool things for manufacturing problems. So that's something that I'm definitely looking forward to. One of my concerns is being able to do astronomy on Earth. Pasadena has some amazing astronomy that happens right here. We have Griffith Observatory just on the mountains here. And so it's really special to be able to go up there and, see Jupiter super clearly, or Saturn or whatever. And, I don't want to have too many satellites so that isn't possible, or we're getting, horrible streaks in our, astrophotography. So that's definitely one of my concerns for the future. But yeah, I think, the technology is already exploding. There's manufacturing, asteroid mining, commercial space stations so that, regular people like us could actually go to space. We're already seeing space tourism. So yeah.
Yeah, I'd love to see a telescope on the moon. I mean, I agree that space pollution is bad, but maybe it'll push us to build that very strong telescope on the moon and be able to see parts of the skies we haven't before.
Yeah, also being able to launch missions from the moon, be able to go further out with more fuel efficient routes, just unlocking all sorts of cool deep space possibilities.
Yeah, I really look forward to the collaboration of different countries coming together to do this as well, because I feel like we've had that happen in the past in big strides, and it's kind of waves and comes and goes, but it really is the thing that kind of will bring us together, I feel like, at the end. And with that, thank you very much, and we'll open it up to questions. Yes, sir?
Sirina, you've been asking a lot of questions. I got a question for you.
Oh, no.
I toured Goldstone years ago, and we talked about not upgrading software in space. But when I toured it, I felt like there were still a lot of 30-year-old computers, like Modcom and stuff, there at the site. And I wonder how much upgrading has been happening lately, and will be happening with these public-private partnerships becoming a bigger role for the DSN.
Yeah, that's a great question, and I'll repeat it just in case. But the question is you visited Goldstone, which I want to know why later, and because it's on a military base, so it's kind of hard to get on there. But it kind of seems so old, and what is happening to kind of upgrade it? Well, first of all, more antennas, because the DSN is so oversubscribed that we just don't have enough bandwidth for everybody, literally and figuratively. And there is like a lunar exploration ground segment coming up with legs. It's called like it's supposed to be specifically for like lunar ground communication, and we welcome that. It won't be managed by JPL, but it's something that could really offload a lot of that sort of thing. There's also like optical communication. So maybe you've heard of DSOC, which I don't know what it stands for, but the Psyche mission, do you know?
Deep space optical communication.
Thank you. There we go. Yeah, I'd be looking forward to seeing those like higher rate missions being supported, because there's a lot of growing pains with missions like the James Webb Telescope and the Human Landing System right now. I mean, we've really had to evolve and create sort of like a route that is very like latency tolerant. Well, it's like a high rate, low latency type of route that we can confidently say that we will not experience any latency when we're talking with people, you know, with humans on board, because the Deep Space Network hasn't supported humans since the 70s. And not only for NASA, but other commercial space companies. So there's a lot of also, I won't call them growing pains, I know I keep saying that, but a lot of technology being developed to sort of support those needs. And with every customer that we have that's new, it's a new feature in the DSN, and that's the way I like to look at it.
Thanks. I'll add as well. So when I worked for Voyager, you know, they did not want to update any of the systems. It's not broke, don't fix it. And so since we're still, you know, communicating to Voyager over the deep space systems, like they need those old computers definitely. And so there's that as well.
I mean, it's built so good. It's built so good that it's not going to break, right? Government dollars. That's the that's the summary. Any other questions? Oh, go ahead. Yes.
Connect the dots for the money for me. This country doesn't like doing things for free. The U.S. government is not just gonna give new space more money just because we can like get something on the moon. So like, where do you see space being more commercialized, or providing some kind of like financial incentive that we can lean on towards the future?
And I'll repeat the question, but what is the kind of financial incentive to, you know, growing and exploring Space 3.0? What is exactly, what are we profiting from?
I'll try to take that one. Software engineer here. I think you've seen some of like the sort of like communication constellations like Starlink. You know, they're going to make a lot of money, and there's a lot of companies that are trying to compete with Starlink. So that's probably like the first wave that's going to cause a big investment in space. Beyond that, we're starting to see a lot of, as you know, costs come down, a lot of business models that weren't previously viable are becoming viable. We're seeing a lot of like image-based hyperspectral things. You can put a camera in space for pretty cheap, look for minerals, things like that. And then finally, I think you mentioned this, there's a lot of just almost, you know, I'm not going to say fringe, but kind of crazy ideas maybe 10 years ago, like in-space manufacturing. The big one that's really buzzy, maybe like 2 months ago, is data centers in space.
It's
Who
cold
knows
in
if that one
space?
will... What?
Because it's cold in space?
Yes, and yeah, I just don't think we have enough, you know, it's also, there's a lot of advantages around energy and things like that.
Yeah, I was gonna say there's another one that's been making buzz, which is putting mirrors in space to try to get more light onto your solar panels on the Earth.
Yeah.
That one's like sort of a buzzy one, but like there actually are like solid concepts for generating power in space and like being able to use it on the Earth, which I think would be huge.
Yeah, and you know, as space gets more important, governments are going to be more interested in space, and if you know you're a world player, you have to have a presence in space, which will also drive lots of money.
Yeah, and that's, I mean, that's really what, you know, like New Space is behind. It's like that that push for innovating, making it better, going for those, again, like underserved community, like underserved like industries that may not necessarily have accessibility to a lot of the different industries. But yeah, the diversity of funding.
Thank you for the question.
Any last questions? I think we're almost at time. Right here.
Terrestrial applications that you think could benefit from the
The question was, is there any terrestrial applications that would benefit?
I think you mentioned. Oh,
oh.
go ahead. Okay.
Like reliability manufacturing is a huge thing for space exploration and space stuff. You can't just go up and, you know, replace a part on your satellite. So I think that we've been pushing like the manufacturing industry to have, you know, their traceability and their reliability be higher. We use a lot of automotive grade parts, and I think it's actually motivated like manufacturers to get their parts certified as automotive. So like our two industries sort of go together in that part. What was your answer?
Oh, just like you mentioned, Ethernet and different types of communicating data on the bus, things like that. Different protocols that we're bringing on the bus as well that have been validated on the ground. I think is, you know, we're bringing that into space as well.
My perspective is that I think the space actually has to catch up with terrestrial reliability. The reason that we can use automotive parts is because maybe in the 90s, you know, there wasn't as many electronics in cars, but as we've gone to, you've seen, you know, mass production of electric vehicles and stuff, like if you have issues in your electronics there, you're like, even like very small issues, you're losing maybe millions, potentially billions of dollars. You want to have reliable parts, and that reliability now of these parts is enabled, like, well, why don't we just put this in a satellite? It's just as reliable as the parts we've been using, and so I'd actually think space has a lot to learn from terrestrial reliability.
Very awesome. Very, very good perspectives. Thank you all so much. If you have more questions, you could just find them after the panel. You guys have a great rest of your conference. Thanks.